Chapter 3, Cellular Form and Function. Section 3.2, the cell surface. All right, Jake, time to tear through Section 3.2 like a goddamn machine. The cell surface is where the real battle happens. Everything your body does, fighting infections, absorbing nutrients, responding to hormones, all goes down at the cell membrane. You slack on this? You fail at understanding how the body controls its internal environment, which means you fail at physiology. And failure is not an option. So lock in. Let's get to work. 1. The plasma membrane, the cell's security system. The cell's fortress. Your plasma membrane isn't some weak-ass boundary. It's the fucking gatekeeper of life. It decides who gets in, who stays out, and what leaves the premises. If this barrier fails, your cell is fucked. It gets invaded, poisoned, or starved. It's not just a wall, it's an active fluid structure. It's selectively permeable, only lets in what it needs, keeps out threats. Composed of a phospholipid bilayer, proteins, and carbohydrates. Lecture note tie-in. Your notes make it clear. Membranes are not rigid. They shift, move, and respond like an adaptable army holding the front line. If the membrane stops working, the cell, period. 2. The lipids of the plasma membrane. Phospholipids, the barrier of life. The plasma membrane is built from phospholipids, fat molecules that create a waterproof barrier between life and death. Your cells don't dissolve in water because of these bad boys. The bilayer is self-sealing. Poke a hole in it and it snaps back together. Hydrophilic heads, water-loving. Face outward, hydrophobic tails, water-fearing, face inward. Cholesterol, 20% of the membrane, stabilizes the membrane. Too much equals too stiff, too little, too flimsy. Glycolipids, 5%, act as cell ID tags. Immune system uses them to recognize friend versus enemy. Lecture note tie-in. Your notes highlight why membranes must be dynamic. If they were solid, cells couldn't divide, absorb nutrients, or react to their environment. #3. Membrane proteins, the workhorses. The true power of the membrane. Lipids make the structure, but proteins do the real work. They're the bouncers, transporters, and signal receivers of the cell. There are 2 types of membrane proteins. Integral, transmembrane proteins, span the entire membrane. Peripheral proteins, attached to one side, act as support structures or enzymes. These proteins control everything happening in and out of the cell. Functions of membrane proteins. 1. Receptors receive chemical signals like hormones. Think insulin docking on muscle cells. 2. Enzymes break down molecules, speed up reactions. Think digestion. 3. Ion channels allow specific charged particles through N+, K+. 4. Carriers transport molecules across the membrane, glucose transporters. 5. Cell identity markers. Immune system uses these to detect friend or foe. 6. Cell adhesion molecules. Keep cells stuck together where they belong. Lecture note tie-in. The notes drill into how crucial membrane proteins are for transport, signaling, and immunity. If these proteins fail, you get disease, organ failure, or death. 4. Second messenger systems. The cell's command system. When signals can't get inside. Not every molecule can barge into the cell. Some just deliver a message and leave. That's where second messengers come in. How it works. 1. Hormone or signal molecule binds to a receptor. 2. The receptor activates a G protein inside the membrane. 3. The G protein activates an enzyme, adenylate cyclase. 4. This enzyme converts ATP cyclic AMP CAMP, the second messenger. 5. CAMP triggers a chain reaction inside the cell to make shit happen. Without second messengers, your cells wouldn't respond to hormones, nerve signals, or immune commands. Lecture note tie-in. Your notes hammer in the importance of G proteins and second messengers in human physiology. 60% of all medications work by targeting second messenger systems. If you don't understand this, you don't understand medicine. 5. The glycocalyx, the cell's identity tag. Who are you? Friend or enemy? Every cell in your body has a unique ID tag called the glycocalyx. This is a carbohydrate coating covering the outer membrane. What does it do? Acts like a name tag, helps immune system detect invaders, enables cell-to-cell recognition. Cells only bind to the right partners. Protects against damage. Cushions and shields the membrane. Lose your glycocalyx, your immune system goes rogue and starts attacking you. That's called an autoimmune disease. Lecture note tie-in. Blood types, AB, ABO, are based on glycocalyx markers. Without the glycocalyx, your body wouldn't recognize its own cells. 6. Surface extensions. When cells need extra tools. Some cells need specialized extensions to do their job. Microvilli, finger-like projections that increase surface area for absorption, like in the intestines. Cilia, tiny hair-like structures that move fluids across the surface, found in the respiratory tract. Flagella, only in sperm cells. This is a long whip-like tail for movement. Pseudopods, temporary projections used by immune cells to engulf bacteria. Lecture note tie-in. Your notes emphasize why these structures matter. They're what allows cells to interact with the external environment. Final recap. Memorize this or die trying. 1. Plasma membrane equals the ultimate security system. 2. Phospholipid bilayer keeps the cell from dissolving in water. 3. Membrane proteins control everything that enters, exits, or communicates. 4. Second messengers, the cell's command relay system. 5. Glycocalyx, your cell's identity tag. Extensions, extra features for movement, absorption, or protection. Closing. No excuses. Lock this in. You don't get to half-ass this and expect to be a serious student. If you're going to compete in nursing school, you need to own this knowledge. Rewind this, write it down, drill it into your brain. No weak-ass memorization. Understand it. Stay locked in, stay disciplined, and don't let up. You're either serious about mastering this, or you're just wasting time. What's next? Are we hitting 3.3, or are you going to take a break like a weak motherfucker? Let's go.